All right, hi everyone, welcome back. So today we're going to look at modulus function, and we are going to define what modulus function is and how is it a very unique process in terms of understanding functions. All right, so the modulus of any number really is what we call the magnitude of a number without a sign attached. So think about, for example, if I find the modulus of 5 without any sign attached, it is just 5. Or in fact, if we say what is the modulus of minus 5, then we say it's 5 as well. Yeah. So it's very important for us to note that the modulus of any number, whether it's positive or negative, will always be a positive number. Now, sometimes we call it also an absolute value. All right. So we can define modulus x in this case as both x, all right, or we can define it as 0, or we can define it as negative x. It really depends if x is more than 0, or if x is equal to 0, or if x is less than 0. Modulus x will make whatever the value inside the modulus sign positive. Okay. Now, some of the key absolute value rules that you need to understand. If we multiply two modulus or two variables together and we want to find the modulus of it, it will be the same as modulus x times modulus y. That will always be true. All right. Now, next one will be modulus of x over y. It's the same as modulus of x divided by modulus of y. That also will always be true. And modulus x whole thing square is just equals x squared, and that will also always be true. Now, how do you verify if it's true or always true? Just try different x value, positive, negative, and see the results for yourself. That is one way that we can verify that, it is always going to be true. Now, for some modulus, it is sometimes true. For example, like x plus y equals to modulus x plus modulus y. It's not always true. So there's some caveat to that, all right? It depends on what is the x and what's the y. So if x and y is negative or a mix of positive and negative, then this may not always be true. Similar to if we find the modulus of x minus y. It may not always be equal to the modulus of x minus modulus of y. Yeah, so take notes of that. All right, so we're going to look at 3 examples of how we solve modulus equation, and we're going to look at the process of how we actually check to see if the answers are really accurate. All right, so let's look at the first one. Modulus of 2x plus 1 equals to 5. So remember, the modulus of any number has both a positive and negative version of it. So therefore, we can say 2x plus 1 is equals to 5, or it could otherwise be 2x plus 1 equals to negative 5. Both are very possible. All right, and then from here we solve. So x will be equals to 4 divided by 2, so 2. And x will be equals to negative 3. Now, from here we are not done, because sometimes in solving modulus equation, there are what we call false answers. So we have to verify if there is any false answer in this case. Now we're going to check by substituting 2 into the modulus. So mod of 2 times 2 plus 1 equals to 5. Okay, so that's correct. All right, for this one. And we're going to check with negative 3. So modulus of 2 times of negative 3 plus 1 equals to negative 6 plus 1, which is the modulus of negative 5, which is therefore equals to 5. So therefore, that is also true. So therefore, these 2 answers are true. All right, let's try the next one. This is the modulus of x squared minus 10 equals to 6. Some of you will recognize that this is actually a quadratic, almost like quadratic equation, right, with the modulus sign. So the process to solve it is very similar to part 1. We're going to split it up into 2 possible equations. The first one is equals to 6, and the second one is x squared minus 10 equals to negative 6. All right, from here we're going to solve. So therefore, x squared equals to 16, and x could be both positive and negative 4. All right, we have to check for all possible answers. Next one, x squared equals to, we're going to bring up 10, so it's 4, x equals to plus minus 2. All right, so quite a bit of things to check, all right, because there's plus minus 4 and plus minus 2. We should just check it anyway, all right? So let's check. Modulus of plus minus of 4 squared minus 10. Now, in this case, whether is it negative or positive, when you square it, it will be positive. So it's 16 minus 10, so that will be mod of 6, which is 6. All right, so both of these answers are true. All right, let's check the next one. If it's plus minus 2, so plus minus 2. Oops, let me just correct that. So the modulus of plus minus of 2 whole square minus 10 equals to minus 6, which is equal to 6. All right, so that is also true. All right, so plus minus 2 and plus minus 4 are possible answers. All right, let's try the next one. This is modulus of x minus 3 equals to 2x. So similar to part 1 and 2, we're going to split the two parts. We're going to say that x minus 3 equals to 2x, or x minus 3 equals to negative 2x. I'm going to solve for it. So x will be equals to, let's see, x equals to negative 3. All right. Over on this side, we will say 3x equals to 3 and x equals to 1. All right. So let's check. Let's see if it's true for both. Now, if we put x equals to minus 3, so we have minus 3 equals to 2 bracket minus 3, so that's minus 6. This will be modulus of minus 6, which is 6 equals to negative 6. That is not true, right? 6 is not equal to negative 6. So we have to reject this answer, or we just say it's not applicable. All right, and we're going to check the next one when we substitute 1. So 1 minus 3 equals to 2. Modulus of negative 2 is 2, and therefore 2 is equals to 2. Yeah, that is true. So that will be correct. All right. So in this free example, you can see that after I've done finding my x value, I have to do a check to see if the answers are valid. Because sometimes you come across answers that are not valid. All right. So you have to take note of that. Okay. So let's talk about graphs of modulus then, especially when we talk about modulus function where fx is linear. So if you talk about any linear graph, it just looks like a straight line graph, like what I've shown you here, when y equals to x. Now, what happens when you draw the modulus function? Basically, whatever that is below the x-axis, in this case, the one that I highlighted in the dotted form, those part of the graph gets reflected above the x-axis, so it ends up looking like a v-shaped graph. All right, so this entire thing will be a modulus function. All right, and that is really how you sketch it. Now, what if we want to solve questions involving modulus function, and how do we solve it by a sketch? So let me give you an example. Yeah. So let's look at example of modulus 2x plus 1 equals to 5. So how do we know the solution? All right, so first and foremost, we will sketch 2x plus 1 as a original graph. All right, and you will see that 2x plus 1 means that it has a y-intercept of 1. And it has an x-intercept of, let me just work out quickly, negative half. Okay, so your original graph will look something like that. Okay, but remember, we don't want everything below the x-axis. In fact, what happens is that this part here will get reflected upwards. So the new graph would look something like this. You get reflected upwards. Yeah, so it's more like that. Okay, so that's my modulus function of 2x plus 1. Okay, it looks like a V shape. Now, to find the solution, we need to draw the second graph. In this case, will be when my y is equal to 5. So y equals to 5 is probably somewhere around here. And there you see the two solution, the two intersection, that will be your solution for x. Okay? All right, now sometimes you may not have a linear function with just a straight line. You may have a linear function and another straight line, but it has some gradient. So let me show you one example. For example, like mod x minus 3 equals to 2x. So in this case, let's plot out our modulus of x minus 3 first. So x minus 3, you have a y-intercept at -3. It goes probably something like that. And it cuts the x-axis at 3. All right? And what happens is that we want a modulus, so everything will get reflected upwards. Something like that. So over here, the intersection, instead of -3, now it becomes +3. So think about this graph as being reflected upwards. Okay? So that will be your function. And the next graph we're going to sketch is the y equals to 2x graph, which I believe it will look probably something like that. Yeah, something like that. And notice that in this case, there's only one intersection, only one solution. All right, so I hope it's clear on how to sketch modulus function and how do you actually find the solution set. All right, so a skilled drawing will be very helpful for you to actually find a solution graphically. Otherwise, you can always solve it by using the algebraic method, by solving it and checking for your answers. Yep, so I hope the explanation on modulus function today is clear, and if you have any question, feel free to drop a message and I'll be more than happy to answer your queries. All right, have a good one. Cheers.